Hello everyone. Now I will show the demo video of the project that I have developed, that is an end-to-end system for detecting and recognizing text in natural scene images using deep convolutional neural networks. So now I'll show that I'll set up the directory uh, for the running the codes and other materials. So in the README document, the step-by-step process has been shown. Now I will set up the Anaconda, open the Anaconda Chrome. Now I'm setting up the directory where all the files are situated. So this is the directory. Now I'm setting up the working directory. Now I will set up the conda environment, but in the README document, it is shown that run, how to set up the conda environment. Just using this command, we can actually set up the environment for running this project. I have already run the environment, so when you will run the write the command, it will actually download and install all the required libraries. So as the uh, as the environment is already set up, so I'm just activating the environment by writing this command called conda activate e2e underscore c underscore Shajib. So the conda environment has been activated. Now it is we can actually run all the codes by following the commands. So for first only single image inference, we can actually run this code end-to-end text detection underscore recognition dot py code by writing this command. And so in this code we will set up the image name, like the image path, which image is gonna uh, be read, and implementing the algorithm. So these are the images path. So by setting up the image name, you can actually run on do the inferences on the particular image. So user can input the image name. So and now I am running the code by writing the command. You can just copy and paste the command over here. So this is the script. Now I'm running the script. So after hitting enter, it will take some time to run the code. So now I'm hitting enter. So it has started working. Uh, Now the code is running. It will take some time for the inference. It has started the inference. So it will take user input for selecting the end-to-end framework method. So we can select one, write one for the first end-to-end framework. So I'm selecting one. After hitting enter, it will generating the results. It will take some time as it is using the CPU for the inference instead of GPU. For the GPU, it will be much more faster in case of inferences. So yeah, the results have been generated, and also it shows the bounding boxes, the text, and also the associated confidence score. Also, it is taking only 12.7 seconds from here, running the whole code, and it also shows that where the images and the uh, CSV files are saved. So in the image results, the images with the detected bounding boxes are shown. So these are the text as well as the bounding boxes. And in the CSV underscore results, there is a CSV file which actually include the bounding boxes, the detected text, and the confidence score. So we can show that the confidence score is pretty good. Now I'll run again the code. So now I will select the second framework. It will take some time. So I'll select the second framework, that is the Pedal-OCR framework. So it has started. So the inference is already done. So it is really much faster than the previous one. It also gives the confidence score and bounding box. So in the CSV file, the results are all listed. So here are the bounding box. These are the detected text and also the confidence score. So the confidence score are here are better than the other. So also shows the results with the bounding boxes and the detected text with the confidence score. Now I will show that it to generate the results for the ICDA 2015 dataset. So it will take some time. So I have already run this code and generated the result files. Now I will do the inference. So if you want to generate the results, then you can simply follow the command and write the command in the anaconda prompt. It will take much time. For EEL68 it will take more than 1 hour, and for EEL68 it will take only uh, 15 minutes or so. So now I am setting up the directory for the evaluation, that is the CLEval directory under the main directory. Now I will just, if we want to do the evaluation for the EOCR, we'll set up this command and run this code script, and it will generate the results. So it can be shown the for the detection, the HPM position and recall are pretty high. Also the recall is pretty good, but for the end-to-end system it is kind of not that much high, because it is showing a trade-off between the performance and speed. So now I can run. So the only reason for this result is that we are adopting the faster version and only inferencing on the CPU and the lighter version. So for the robust version, and if we train with much more diverse data set and use GPU for the inference, then the results and the performance will be higher. So now I will do the same thing for the parallel OCR generated result. I'm just writing this command, copying and pasting over here, and it will generate the results for the second framework. So here the HMIN is a little lower, but precision is higher than the end-to-end framework. So it uses differential binarization rather than craft. But in case of end-to-end HMIN precision recall, it is higher than the end-to-end framework one. So that is a good thing. So these are all